Hello and welcome to the presentation of the paper "Thy Algorithm Shall Not Bear False Witness, an evaluation of multiclass debiasing methods on word embeddings," written by myself, Thalea Schlender, and my co-author, Gerasimos Spanakis. The motivation behind this paper is that biases are still present in artificial intelligence applications, and these may amplify biases already present in our society. This becomes extremely dangerous in sensitive domains such as hiring, the justice system, or medical domains. When I talk about social biases here, I mean the discrimination of certain identity groups based on, for example, their gender, race, or religion. From now on, I will refer to textual data only. Specifically, I will refer to biases in word embeddings. Word embeddings map a word to a real valued vector trying to capture the semantics of the word. Biases have already been found in word embeddings. Thus, gender bias has helped coin "man is to computer programmers, woman is to homemaker," and the racial bias is found in "black is to criminals, Caucasian is to police." The biases within these word embeddings have mirrored causes. However, common cause is the common co-occurrence of words with identity terminology. Thus, the word embeddings then capture this association, which is fundamentally wrong. Having outlined why the mitigation of these biases is vital and having introduced the domain of biased word embeddings, this paper investigates the problem of multi-class social bias in word embeddings resulting in possible discrimination. Thus, this paper now researches state-of-the-art multi-class post-processing debiasing techniques. This is done on religious bias as an example for multi-class bias, which has not been used in literature so much. From this, the research questions follow. To what extent are religious bias present in widely used word embeddings? And how does the performance of state-of-the-art multi-class debiasing techniques compare geometrically in downstream applications? First, the overview. An analysis of analogies in word embeddings will be given to provide the need of debiasing in a word embedding. Then the three bias quantification techniques, WEAT, MAC, and RNSB, are going to be presented. Before the three bias removal techniques, hard debiasing, soft WEAT debiasing, conceptor debiasing, are explained, and our results are portrayed. The analysis of religious stereotypical analogies is done on Word2Vec. Below in the table you can see appropriate analogies, which also include Muslim is to Islam as Christian is to Christianity, which is an appropriate analogy since it correctly associates a religion member to its religion. The scores of these analogies are given. Stereotypical analogies score similarly high. This causes unfortunate features to be attributed to each of the religions. These unjust features include Christian being related to judgmental and conservative, Jew being related to greedy and hairy, and Muslim being related to terrorist and violent. Now the bias measuring techniques. First, some terminology is defined. A class is a factor on which an identity group is defined on. In this paper, this is religion. A subclass are different subgroups of this class. For instance, Christianity, Islam, and Judaism in this paper. A target set is a set of words referring to a subclass. For Christian, this could be church, Bible, Christian. An attribute set are a set of words concerning one topic which should in theory not be related to any subclass more than the other. An equality set denotes an equivalent concept within all subclasses. An example of this is church, mosque, and synagogue, since all three terms describe a house of worship for religion. The word embedding association test WEAT is the most widely used. It is a relative geometric measure which performs a statistical test on the equivalence of associations between target set 1 and attribute set 1 and target set 2 and attribute set 2. Associations here are defined by cosine similarity. The mean average cosine similarity MAC is similar to the WEAT. However, it measures average associations of one target set to all attribute sets. Associations are measured by a cosine distance, an optimal value being 1. The relative negative sentiment bias, RNSB, is our downstream evaluation of bias. We encode unbiased words via the word embedding to be investigated. We train a logistic classifier to classify positive and negative sentiment. Then we ask the classifier to predict probability of identity terms being classified negative. Then we take this distribution and compare the negative sentiment distribution to a fair distribution. Intuitively, a fair distribution would be a uniform distribution, signalizing that all identity terms of all subclasses are equally likely to be predicted to be negative. Onto the debiasing Hard debiasing is the first debiasing technique, which was proposed by Debiasing and brought into the multiclass domain by Mancini. It works by finding a bias subspace via principal component analysis on the previously mentioned equality sets. Two steps follow. The neutralize step, which removes the projection of neutral words onto the bias subspace, and the equalize step, for those words who rely on the bias component by definition. We center the equality sets and make biases component each of the same magnitude. The next debiasing techniques is soft WEAT, as proposed by Popovic et al. By doing the WEAT test, the attribute sets are determined against which each subclass is biased against. Target sets are projected onto the null space of the bias attribute sets. A projection is scaled by the hyperparameter lambda, and this projection is only applied on the target sets. Next, we have Conceptor Debiasing. Conceptor Debiasing was proposed at Carver et al. And works via a soft transformation via conceptors. Conceptors act like filters, and they have the attributes that conceptors can be manipulated by Boolean logic. Thus, we can capture bias via a conceptor and then apply the negated conceptor to filter out the bias. Another positive attribute about conceptor debiasing is that by Boolean logic, we can combine different conceptors together to enable joint debiasing. These three debiasing techniques are applied on three widely used word embeddings and evaluated by the bias measurement techniques mentioned earlier. Here are the results. The RNSB. With significance of alpha equals 0.05, all debiasing methods remove bias significantly. Hard debiasing improves RNSB the most. The relative negative sentiment bias works by comparing a negative sentiment probability distribution to a uniform distribution. Here we have shown the negative sentiment probability distribution in Word-to-Vec. It can be seen that hard debiasing distribution looks like the uniform distribution a lot, whereas conceptor debiasing changes the original non-debiasing distribution to Islam being the least probable to be predicted to be negative. Soft WEAT only dampens the distribution. Onto the geometric evaluation. Here the WEAT and MAC scores can be seen. In WEAT, hard debiasing seems to improve the bias scores the most, whereas in MAC, conceptor debiasing decreases the bias the most. When looking at the tables more closely, it can be seen that soft WEAT debiasing, when applied to ConceptNet, increases the WEAT score by 8%. Also, when soft WEAT debiasing is applied to ConceptNet, the MAC score is increased by 174%. Hard debiasing has performed superior in all prior measurements. However, when concerning the MAC scores, it can be seen that hard debiasing increases the score when applied to ConceptNet by 20%. However, with the significance of alpha equals 0.01, debiasing methods improving the MAC or WEAT scores do this significantly. Hard debiasing's poor performance can be explained by the fact that it equalizes the bias in the subspace, so all religions are just equally biased against the attribute sets, however they are still biased against them. In conclusion, the largest bias removal via downstream bias measurements was measured with hard debiasing. The largest bias removal via geometric measurements was recorded with conceptor debiasing. Hence, the overall recommended debiasing method is conceptor debiasing, which achieves an average decrease of 82% for Word-to-Vec, 97% for GloVe, and 55% for ConceptNet. In the future work, we would like to combine this examination of post-processing methods with a pre-selection of data to decrease the bias further. Here are the references used throughout the presentation. Thank you for your attention. Any comments would be greatly appreciated.